Dominik has just emigrated from Switzerland, has been in Australia for about four days, and we're delighted that he's able to come and be part of the Adelaide Mini Makerfaire. Now, Dominik's a scuba instructor and a computer engineer, and has brought along his OpenROV robot, and I'm sure you'll be delighted to learn a little bit more about what that all is. So please welcome Dominik.
Hey there. Nice to be here. So if I should seem a bit jet-lagged, sorry for that. I really just arrived Wednesday. So I'm here to talk about OpenROV. It's a project that should help people like you or anyone else to see what's down there in the ocean or in a lake or in a cave or whatever. It's basically a way of building a project that can help citizen science or scientists to discover things. As you see, we just the next issue of the Maker magazine happens to be with one of the OpenROV founders. It's Eric Stackpole. He's a NASA engineer. Now, if that works, no, it doesn't. No. There we go. So OpenROV. It's our little logo. We plan to, or we have a project to make people explore and educate. I think you only can protect something if you know about it, and as human beings can't go underwater except if you're scuba diving or snorkeling, you can't really see what's there. And some places are too deep, too dangerous to go. So we built a little project that doesn't break the bank. It costs probably $800 to build it. Sounds expensive, but a little bit more on that later. So that's me. That's my Twitter handle. Follow me, send me an email if you need anything from me. If you want to know something about the project. I'll be around here today and tomorrow in Adelaide, and then being back in Brisbane for some time. To myself, as I introduced before, I'm a developer by heart, doing software development since 12 years. I'm a diver as well, so 7 years ago, learned scuba diving here in Australia. It's beautiful. It's much warmer than in Switzerland. We get 6 degrees water temperature. That's a bit cold. So I'm happy to be back, and I'm just starting to become a maker. I'm developing stuff since many years, but I never considered to be a maker. Just happened to have seen that project mentioned somewhere on the web and thought, hey, wow, that's cool. That's scuba diving and technology. I'm going to do that. I started building it, started to mess with their software and be part of the system of the project right now. I'm one of the contributors to the software, and, well, I'm here today presenting it to you. So, what is a ROV? ROV stands for Remote Operated Vehicle, and basically it's a guy like that one, and have seen those probably used to discover the Titanic, help to find the leak on the deep sea horizon or deep water horizon, find all kind of stuff. But what do you guess? What does a guy like that one cost? That's probably higher than a person's height. So probably a couple of $100,000. And they probably have run costs per day far beyond like $1,000, if that's at all. So OpenROV, it's not going to go where the other guy went. We're not going that deep. It's more about going probably up to or down to 100 meters. That's what our technology we have right now is capable of. a little bit more on that one later. But we go down to 100 meters. That's further than most divers go. If you're an open water diver, you go to 30 meters maximum. Tech divers, well, they go down to 100, but that's a big plant and just a few minutes. And if you want to go probably back to that one, the cheapest discovery type of OpenROV, of ROV I saw on the internet was about 30,000 US dollars, and then it gets table sized. You could afford that probably, but still, it's for a maker or for a person like you and me probably not going to work. So we started OpenROV, and it's actually to discover things. You see here, one of the ROVs actually went to Antarctica with Eric Stackpole, one of the founders of the project. It is based on cheap, widely available material. You see my little prototype there in front. It's made of acrylic plastic. It's made of some wires. It's made of a beagle bone board. You can buy that for a few dollars. It's made of RC plane parts, like the drones you see probably up there. We have RC motors on that. Brushless motors, just throw them in the water. They will happily continue to work. Just need to make sure that everything else is made watertight. But the motors will work. Probably not for the entire life of the planet, but at least for a few hours. Just let them run dry afterwards when you take them up out of the water, and you're fine. So as you see here, been to Antarctica, and that's from a freshwater lake somewhere in the States. We have people in 75 countries that are signed up on our website. We sell kits for those, and we sold over 100 kits, and it's going to be big across the globe, especially US. A few kits went here to Australia, to New Zealand, and it's really starting. We have a big base, and people can't start to contribute, but you'll see a bit of that later. So how's the OpenROV working? As I said, it's open source. What does open source mean? We put all the plans to cut the acrylic plastic on the web. It's a PDF, it's a DXF, whatever file format you need. Put it on one of those laser cutters out there, and it will cut the pieces for you. All fine, all open source. If you have a great idea of making something better, just change it, just send it across to us and we can integrate it. Or you just can join the project more deeply and help us to achieve more things. On the other side, it uses open source software. We run a fully fledged Linux on that box, running a Node.js server, a little bit of JavaScript if anyone's familiar with that one. We have stock parts, as I said before, RC model airplane, motors, props from RC planes. We use standard batteries. In my version, I use a rechargeable battery. The standard project comes with 8 C-cell batteries, and that gives a runtime of about 1.5 hours. So pretty decent, and we have lots of technology. We even have some people discovering ways of sending power from the topside to the Beagle Bone CPU and to power the ROV. So have a big battery on the topside or a generator, and it powers the ROV. That would be awesome. We're not there yet, but we're on the way. So here you go. We have a store, an online store. I'm not going to tell you go and buy it from there. Feel free if you want to build one. Our ROV costs in that store $830 to order. Probably sending it to Australia costs a bit of shipping as well. We will have to work that out. But if you take those $830 and compare it to 30,000, it's a big difference. And it's actually a big difference as well for schools and universities. They might not afford a $30,000 ROV to explore the local reef. Just someone that is interested in seeing what is down in a lake or down in a quarry, it doesn't work or he can't go and buy a ROV for $30,000, but he probably can afford $800. If you can source the pieces yourself, if you can cut the acrylic yourself, you're probably down to $500-600. You can make it cheaper. We have a guy doing exchanging the beagle bone, which is a bit more expensive, like $80-90, with a Raspberry Pi, which costs like $25-30. I don't know what it costs here, but it's amazing. People just change it, and it works. So all those red dots you see on the map there, those are people involved in the project. They are either bought a kit from us, or they are joined our website, or have joined the Google Groups mailing list. So it's pretty impressive. And yeah, we shipped over 100 kits into more than 75 countries across the globe. I think somewhere around 400, 500 members in our online site, contributing through forums and through the wiki. And yeah, that's how it really started. It was an idea, and Eric Stackpole and David Lang from San Francisco, they were like hearing a story of someone having put gold from the time of the gold rush down into an underwater cave, and they wanted to find that. Now, cave diving is pretty dangerous, and you should be trained properly to do that. But they thought, hey, we could build something to find that gold. So they went on, and they probably were not these hardware designers at that point, but they thought there will be someone out there that can help us with that one. So they put up a site. They started with models of that one, like 15, 20 different iterations, and they put all the plans on the internet. They built software and they put it on the internet, and slowly people started to talk about that one. Eric is actually driving ROVs for NASA sometimes as well, and through that and through the connections around San Francisco, he got lots of people to know and lots of coverage as well on the media, especially on internet, Twitter, Facebook, and that's going to help the project, or went to help the project. At one point, they thought about building a Kickstarter project. Not sure if you heard about Kickstarter. It's a crowdfunding platform. There's a few of those around. Possible is another one. Not sure if there is an Australian platform yet, but I'm sure there will be at one point. You can put up projects like that one up there and ask people to spend some money on it. For a little bit of money, you probably get a mentioning on the webpage. Spend a little bit more, and you get a free CD if it's a musician wanting to create a CD. With that one, you could pledge some money, get one of those caps. You pledged more, you could get pieces like the acrylic kit. If you pledged even more, like the 380, you would get the complete kit sent to you. You just have to build it yourself. Now, within a few hours, the $20,000 that were set out were achieved. We overachieved by a few 100%. David Lang is actually going to write a book about that. So if you're interested in how to make that successfully, go and read that later. If you plan to build your own, you might want one of those. It's a bad quality picture where it shows the laser cutter cutting my ROV's shell. There is a little bit smaller version of a laser cutter around here. Have a look how they do. I think they're cutting wood, but acrylic works as well. You just put the acrylic in the laser cutter. Start your PC. It shows up as a printer. You print the file, and the laser goes away, cuts it out for you. All what you have to do is to bend the shell down and to glue the rest together. If you buy the kit, or if you build it your own, you probably end up with something like that. Those are more or less all the pieces you need, and they fit together nice and cozy in the electronics tube. You can build it up. So all those plans, all that software set is open source. Anyone can get it, anyone can use it, and anyone can contribute. GitHub, it's a very popular repository for source code, and we put everything on there. We put the software on it, the hardware. We have a contributions thing. We have electronics. We have an additional board to the BeagleBone to power all the servos and have a power management on it. And that is the files to print that PCB board is actually on GitHub as well. And we already got some contributions in that regard. So people thought, hey, you can make that better. So we go and incorporate that into the next batch. Now, if you want to build one, you go buy plexiglass, acrylic glass, and all the other pieces. You start building it, and you probably will end up on our wiki. It's a great way of sharing information. We have contributors to the wiki from all over the planet. I done a bit. The guys from San Francisco did lots of it. And some people just came up and said, hey, cool project. I can't build it right now, but I can improve on your wiki page. We have all the documentation out there, and it's so cool to see everyone contributing their findings and how to do things better, how to make it easier when building the project. Besides the knowledge sharing on the wiki, we use Google Hangouts. We're a global project, so we want to meet, and Google Hangout is a great tool. It's video conferencing across the globe. It's awesome. We had video conferences with people from, in the same video conference, had from Antarctica, San Francisco, Germany, Switzerland, and Belgium. And it's just awesome to see all the people coming together, speaking about the project, developing it further. And the good part is it's automatically archived on YouTube. You just go watch it again. It's a great way to store some information. So where do we go with it? Right now, it's fully functional. If you build it up, you can put it in a lake or in the sea and go and have a drive. Software is constantly evolving. Hardware is evolving as well. First iterations, we used a little device to put the Ethernet on a twisted pair cable. Now someone came up with the idea of using home plug adapters that use your DC current electric system in your house to send data across. It has a much higher bandwidth than the stuff we used, and we just incorporated that into it. It is really cool. Haven't worked with it myself right now, but I will, definitely. So where do we go? We have contributions like for battery pods. Right now we just use like plastic rubbery end caps that we pot the cables through. Someone came up with, hey, I can 3D print those things much better. And yeah, there we go. That's probably going to be in the next iteration of the project, printing the end caps for the batteries, and as well printing on the lower picture, printing the end caps for the electronics tube, because right now we use acrylic that is welded together. Someone came up with a great way for the props, because right now our motors run in the water. That is hurting them a little bit. Someone designed a pod that even could be made movable, so it could actually adjust. Ours are just static right now. Someone's designed a manipulator, an artificial hand, as you see on the big ROVs. Someone's just designing that one, and we're going to use that most probably at one point on the ROV. We plan to incorporate like standard modules of software that you just can activate. So if you add a manipulator, you can include the manipulator software, and you just go and have it available. To use the ROV, actually, you use a laptop on the top side. I have an electrical problem, otherwise I could have shown it, where you just have a UI in your web browser. You just browse to the ROV. It has a web server on it. You browse onto it, and you have the video, and you go and steer with a gamepad or with the keyboard. It's fantastic to, even if it's on the bench top, to go there and press a button and the little motors start to spin, or the lights light up. That's so cool. And there is more to come. We improve the software constantly. Now, as you see, we are on the Maker magazine, as I mentioned before, and there will be the NASA International Space Apps Challenge happening on the 20th and 21st of April. There is a venue here in Adelaide. Not entirely sure where it is, but you find out on their webpage. I'll be in Brisbane at that time. The guys from San Francisco will join in. It's a global challenge and global networking event. Many people do crazy stuff there, like thinking about catching meteorites and all that crazy stuff. It's really cool. It's going to be great. So hang around. You can join online as well. Will be cool. Yeah, that's about it. I'll be hanging around. If you want to have a look at the ROV, comment and ask me. Out on the counter there are little badges. You can get one of those. If you want to rate my speech or the presentation, go for it. I'll put the slides up somewhere. I think we can organize that with the Makerfaire afterwards if you want to have a look. And thank you for your audience, and have a look.